Today, we're diving deep, literally, to see how we're unlocking enormous hidden energy reserves from way out beneath the ocean floor. And we're doing it with some of the most massive and complex machines ever built, floating factories.
So, just imagine this for a second. You find a huge natural gas field, an absolute jackpot, but it's hundreds of miles from shore, and the water is way too deep for a normal pipeline. This is a real problem. You've got this incredibly valuable resource, but it's completely stranded. So what do? How do you possibly get that energy to the rest of the world?
Well, this is where the genius kicks in. Instead of trying to build an impossibly long and eye-wateringly expensive pipeline back to a plant on land, engineers just flipped the whole problem on its head. They said, okay, let's build a totally self-contained, floating factory that can sit right on top of the gas field. And that, right there, is the whole idea behind floating LNG.
Now, to really get how this incredible floating factory works, we first have to understand the substance it's built to create, liquefied natural gas, or as you probably know it, LNG.
So what exactly is LNG? Well, at its heart, it's just natural gas, mostly methane, that's been chilled down to an unbelievably cold liquid state. The entire goal here is to take a gas, which is hard to move around, and turn it into a stable, easy-to-transport liquid that we can then ship literally anywhere on the planet.
And here is the magic number that makes this whole thing possible. When you chill natural gas down to minus 162 degrees Celsius, it shrinks a lot. It takes up just 1/600th of its original volume. To put that in perspective, imagine a giant beach ball shrinking down to the size of a grapefruit. That incredible density is what makes LNG so efficient to store and ship across oceans.
And that's the whole point, right? The entire reason these enormous facilities exist is to take that raw gas from the seabed and convert it into transportable LNG, all while floating out on the ocean.
But how do they actually pull it off? It's an amazing process. So let's follow a single molecule of gas on its incredible journey through this floating factory.
The whole trip happens in 4 main stages. First, the gas gets pre-treated as soon as it comes up from the well. Next, it goes through this intense purification process to get rid of all the gunk. After that, it's time for the deep freeze. That's the liquefaction part. And finally, it's stored on board and then offloaded onto other ships.
And get this entire incredibly complex factory fits onto a single vessel. So let's follow the flow. The raw gas comes shooting up from the seabed and enters through this giant rotating connection called a turret. This thing is amazing. It actually lets the whole ship pivot with the wind and the waves. The very first stop inside the factory is pre-treatment, where the gas is stabilized before the real cleanup begins.
You can think of this next stage as the ultimate cleanup crew. Before you can even think about chilling the gas, you have to get rid of anything that could freeze or cause damage. I mean, CO2 and water, they just form ice and clog up the pipes. Mercury, that would literally corrode the equipment from the inside out. They even pull out heavier stuff like propane, which becomes its own separate product, LPG. Every single impurity has got to go.
Actually, wait a sec. Even before the gas gets to the facility, there's this other crucial step. You see, as gas travels up from the deep sea, it's under high pressure and it's cold. That's the perfect recipe for water and hydrocarbons to form these nasty ice-like crystals called hydrates, which can completely block the pipelines. So to stop that, they inject a kind of antifreeze called monoethylene glycol right at the wellhead.
Okay, so once the LNG, LPG, and all the other byproducts are made, they have to be stored in these enormous cryogenic tanks deep inside the ship. And these are not just big tanks. They are basically the world's most sophisticated thermos flasks. They're built with layers and layers of insulation to keep those liquids at their super cold temperatures for days at a time.
And that brings us to the very heart of the operation, the art of creating extreme cold. I mean, how on earth do you chill natural gas to minus 162 degrees Celsius efficiently and safely on a moving platform in the middle of the ocean?
Well, there are a few different cooling technologies out there, and each one has its pros and cons. Some are super efficient, others are simpler to build. But when you're on a floating facility, safety is everything. That's why a process like nitrogen recycle is so compelling. It uses a non-flammable refrigerant. That is a massive safety advantage when you're miles and miles from land.
So here's a look at one of the more popular high-efficiency methods, called DMR. It basically uses 2 different refrigerant loops. The first is a warm one that pre-cools the natural gas part of the way. Then a second, much colder refrigerant loop takes over to do the final deep freeze into a liquid. It's complex, for sure, but really energy efficient.
And here's that safer alternative we were talking about, the nitrogen recycle process. Instead of using flammable stuff, it gets cold by rapidly expanding compressed nitrogen gas. You know how a can of compressed air gets freezing cold when you spray it? It's that same principle, just on a massive industrial scale. It totally avoids flammable materials, which is a huge boost for safety.
So let's recap. We have a floating factory that can pull gas out of the seabed, clean it up, and liquefy it, all while floating miles out at sea. So why is this such a total game changer for global energy?
Well, the benefits are just enormous. For one, it unlocks gas fields we once thought were impossible to get to. It avoids those super expensive deep-sea pipelines, and it seriously minimizes the environmental impact on our coastlines. It even uses deep seawater to make the cooling process more efficient. But here's the most incredible part. When a gas field runs dry, the entire factory can be disconnected and sailed to a brand new location. It's a truly mobile energy solution.
And now for the payoff. The final step is getting that LNG onto a carrier ship. And this is like a delicate dance in the middle of the ocean. You have two massive vessels moored side by side, and these specialized robotic-looking loading arms connect them to transfer that cryogenic liquid at -162 degrees. It's an amazing sight.
And this right here is the result of that entire incredible process. A giant LNG carrier filled with energy that started its life deep beneath the ocean floor. It's now ready to sail to markets thousands of miles away, powering homes and industries all across the globe.
It is an absolutely astounding feat of engineering. It literally turns the ocean itself into a production platform. And that leaves us with a really critical question. As the world's energy needs continue to change, are these incredible floating factories the crucial bridge to our energy future?